Hello and welcome back everyone. In this video, we will be writing a function that will sort all the unique elements of a given queue in the front and all the elements that are not unique or are being repeated at the back. Then without any further delay, let's begin. So I will write a module and I will call it test. And let's call the queue as queue, and every elements of the queue should be of int data type. So what I'm going to do, I will be using an output queue that will have our desired pattern, that is all the unique elements will be in the front of queue and all the repeated elements will be at the tail or back of queue. And I will be also using another supplementary data type that is associative array, and I will let you know why. So first let's declare another queue and let's call it queue2. And then I will declare an associative array, and I want the elements of that associative array to be of bit data type, and let's call that associative array as ASSOC, and all the elements, all the index of that associative array will be of int data type. So let's begin with our initial block. So the reason I will be using associative array is because of the exist method. So the exist method checks whether that particular index already belong to that particular associative array or not. So we will be using that exist method in the if and else condition just to sort out the unique elements at the front and the repeated elements at the tail. So what I will do, first I want to iterate through each element of the queues, and for that I will use the for each loop, and then I will write the queue and let's call all the elements as I. And then inside the for each loop I will be using if condition to use the exist method of the associative array. So if ASOOC, if that particular index exists inside the queue, and I will be iterating through each elements of this particular queue, so I will be referencing each element as the index. So if it exists, which means it is not unique, it is being repeated. So if it exists, then I will push that particular element at the tail of the output queue. And I will use the pushback method. And if you are unaware of these methods that we are using here right now, you could refer to my data types videos about associative arrays and queues, where I have mentioned all the methods with examples. So if that elements exist as an index of this associative array, then I will push that element at the tail of the output queue. And if it does not, else, and let me rectify this as and, else, which means it is unique. So if it does not exist, we will just include that inside the associative array as an index, and also we will push that element at the front of the output queue. So I will write so the reason I am writing the type of the data elements of this supplementary associative array as bit because the data does not concern us, because at last we will be comparing the index. So we will be taking that element. If that element is unique, we will put it as an index of that associative array. So I will write it like this. So I will assign that particular element of this queue, if it is unique, as an index of that associative array, and we have to assign some values because after all it's a linked list. So I will assign a simple value of 1, which is of 1 bit. So the value does not concern us. The main thing is index, because after all we are comparing index whether it exists or not. So if that's the case, if it is unique, we will just note that index and we will assign a value of 1. And also, since it is unique and as per our requirement, all the unique elements are required to be at the front of the queue. So we will just use the push front method for the Q2. And we will put the very same element inside it. Also, I forgot to declare the values of that queue. So let's go ahead and write some random values. So let's assume that this input queue has certain elements, and let's say 1 and again 1 and 2 and 3, 6. So I am just putting some random values, and let the next value be 2 and 1, 7, 6, again 7, 7 and 2 and 3, then 2, 1. Let's add few more values, 6, 7, 4 and finally 9. So as you can see that if you will count the unique values, then we have 1, 1 and then 2 and then 3 and then 6 and then 2 is already has already appeared, so it's not unique anymore, it's rather a repetition, and 1 is also being repeated, then 7, then again 6 is being repeated, 7 is being repeated, and again then 2 is again being repeated, and same goes for 3, 2 and 1 and 6 and 7 and 4, and finally 9 is unique. So we expect, it does not matter whatever the order is, we expect all the unique values to appear at the front of the output queue. And since we are checking it from front to tail, it will be something like this, that the very first element will be 9, then 4, then 7, then 6, then 3, 2, 1, and then these values are being followed by the tail, by the repeated values. So let's just go ahead and check whether I have made any typos, and also just to display the value of the queue, I will use a simple $display system task. And let us just output the value of Q2, which is the output queue. So once again, I will repeat, we are using associative array just to use the exist method, which make this sorting very convenient for us. And uh, we are not concerned whatever value the associative array holds for each of its elements. We will only use the exist method that works with its index, and then we will compare the index with each of the elements of Q just to check whether it already exists or not. And if it does not, then it means it is unique. And if it is unique, we will assign that particular element of Q as an index, and we will assign the value 1. And it does not matter, you could also assign 0, since I have taken a bit data type. And the thing that matter is to uh, put that particular value in the front of our output queue. So I will just use some indentation here. So let's open the QuestSim and let's check for any compilation error. Okay, we do not have any errors. So let's go ahead and start the simulation. So let's see what we are getting right here. So as I have told that since the comparison is being done from front to the tail, the very first element will be 9, 4, 7. Okay, then it is followed by 6, then 1 and 2. So okay, yeah, as I have told you right here, that very first value will be 9, 4, 7, 6, 3, 2, 1, and you could see it right here. Okay, so 3 is being thrown after the 2, and yeah, that makes sense. So you could see that all the possible unique values that we have right here, 1, 2, 3, 6, 7, 4, 9, are at the front of the queue, of the output queue, that is Q2. And right after 3, we have all the repetitions. And then 2 has already arrived. So from here on, every elements are nothing but the repetitions of the unique values which lies at the front of the queue. So after that we have 2, 7, 7, 6, 7, 1, 2, 6, 3, 2, 1, 1, 1, 2, 1, 6, 7, 7, 2, 3, 2, 1, 6, 7. So this function basically did what we wanted. It sorted all the unique elements present inside the queue at the front of the output queue, and all the repetitions are thrown or pushed at the back of the output queue. So we are just using associative array as the supplementary uh, data type for which uh, the exist method matters to us. And if I will print the associative array, you will see that it will only have the unique elements, and all the unique elements will have the index. So yeah, all the unique elements will be there inside the associative array as an index, and each of them will have a value of 1. So let's go ahead and also print the value of the associative array. So I will compile the code for one more time. Okay, everything works fine. So let's start the simulation. As you can see it right here that it has all the unique values of the queues as as the indices, and all the indexes have the value of 1. So 1 is there, 2 is there, 3 is there, 4 is there, 6 is there, 7 is there, and 9 is there. And these are all the unique values as we have discussed right here. So I hope you find this video useful and stay tuned for more. Thank you so much.